Okay. Hello, ladies and gentlemen. I got to do a couple problems here that came up in seminar repeatedly, so I wanted to make sure that I addressed them. Okay, these are the ones about finding the function or evaluate the function and find the sum. Okay, well the first one is geometric, and by the way, since it is alternating, r is really equal to -1/4, but it did say find the function. I am going to do it as a find the function, but we'll also do it as just find the sum. So if you remember, if it's geometric, it's going to use the function 1 plus x squared plus x cubed, ... But what function was that? It was 1 over 1 minus x. Okay, so in this case, x is -1/4, so it's 1 over 1 minus -1/4, which is 1 over 5/4, so that sum is equal to 4/5. Okay, and that's really the same thing as how you'd find the sum. So if you just used this, that would have been fine. Okay, all right. So the second one, I can't tell. I think I had 6 people in at seminar. All 6 of them asked for number 9. So I'm going to do 9, and I'm going to do 21. I don't remember if that one was assigned or not. But if you look at this one, okay, this is the sine function. Okay, this is the sine function evaluated at what value? At pi. So this is the sine of x evaluated at pi. But by the way, you're just basically working backwards. So what is the sine of pi? It's simply 0, and that's your sum. Done. Function, sum. That easy. Okay? So if you look at 21, this is the series for e to the x, because it's 1 plus x squared over 2 factorial plus x cubed over 3 factorial, ... Well, in this case, x is equal to the natural log of 2. Okay? Because that's what we're substituting in for each of these. So what is e to the ln of 2? Well, these are inverses of each other, so that sum is just simply 2. Okay? What is the function? It was e to the x, was the series, evaluated at natural log of 2. So what is the value? It's just 2. If this would have been the natural log of 4, then it would have been e to the natural log of 4, which would just give us 4. Done. Okay. 43 is a little bit of a stretch for right now, but this is one of the ones that's true for an AP exam. Questions, I know this one has come up. Okay, I want to point something out. When a series converges or diverges, it's not the first few terms, it's the tail. It's the last ones that determine whether it converges or diverges. So, for some value of n, in fact, this is true. In fact, this is true as long as n is, it's bigger than 1 as long as n is bigger than e. Okay, so if you think about it on a number line, here's e. Everything after that is where we determine whether it converges or diverges. So we can make this statement as long as n is greater than e. Okay? And we know that the natural log of n is always smaller. The natural log of n is always smaller than its input of n. Okay? This I'm going to use what's called a squeeze theorem because it's much easier to see. Okay, if this is true, now what I'm going to do is I'm going to take each of those and I'm going to divide them by n cubed. Okay? So I get over n cubed, I get over n cubed, and I get over n cubed. Okay, so this is 1 over n cubed, and this is actually the series I have. Okay? So I actually squeezed it between 2 series. Well, this is a convergent p-series, and this is a convergent p-series. And if we squeeze a series in between 2 convergent series, what must it do? It must converge. Okay, this would be one of those that could be on an AP exam multiple choice, but I at least wanted to show you how to do it. You don't have any tools that would allow you to do that because if you do every test on it, at this point, you wouldn't get anywhere with it. So I at least wanted to show you this one. I would not test you on that one at this point, but you could see that one coming up later. Okay? All right. Last one I want to do is number 57, because 57 I answered multiple times today too. All right. And by the way, because it's a Maclaurin, because it's at 0, you don't need to go through the Taylor process. Okay? You don't need to go through the Taylor process because you'll never find the general term. Okay, you will never find the general term if you try and do the whole Taylor process. You can only do like P sub 5, P sub 6. You're never going to get P sub n, or you might be able to, but it's really difficult to see it. So I'm going to do here's the sine of x, and I'm first going to do the sine of x over 2. So that's it. I just substituted in x over 2. Okay? But now we got to do the last part, which is multiply by 5. So there is our series. I substituted in x over 2 everywhere for x. There's my series. And now I just multiplied each term by 5. So here's my general term. Okay? So that is the first 3 non-zero terms in the general term. So there they are, the first 3 non-zeros. And that's an x over 2 in the general term. Okay? So now we want to find the interval of convergence. So I have to do the ratio test on that on this term. So it's over 2n plus, it's the 2n plus 3 power here. It's 2n plus 3 factorial, this one here. So if I look at these two, and by the way, there should have been a 5 here also. The 5s are going to cancel. Okay? You're going to get an x over 2 squared left over with these two terms. And you're going to have, with this factorial, 2 terms left over. Okay? So if n goes to 0, or is to infinity, this goes to infinity on the bottom. Remember, when that happens, you really should move it over to the other side. And what do I get then? Well, I get infinity, which therefore converges for all what? X. Okay? So the interval of converges, it converges for all x. But wait a minute, it's sine. And by definition, the Maclaurin says it's convergent for all what? X. Now you still needed, so whether it said show your method, you still needed to probably do this, but you were just confirming that it was that fact. Okay. And the last one was C. It says, what is the minimum number of terms this series is needed to approximate f of x on this interval with an error not exceeding 0.01 in magnitude? So really, we're trying to find the error and keeping it less than 0.01. We need to figure out how many terms. Well, first of all, it is alternating. It's decreasing, and it will decrease to 0. By the way, any series with sine of x or cosine of x will alternate, decrease and decrease to 0, simply because it's convergent for all x. Because of that, all of our error is going to be in our next term. So we are only looking on negative 2 to 2, but it doesn't matter whether I plug in negative 2 or 2 in all these. My error is going to be positive because error is always what? Positive. Okay, so I want to look at the error of P1, which is the error of this one. So I have to look at the next term. Okay, doesn't matter whether I plug in 2 or negative 2. Because it's an absolute value, I'm still going to get the same value. Okay, so the error of the first term is all in the second. Well, if I work this out, this is 1 to the third, and I get 5/6, which is bigger than 0.1, so it can't be that one. So I need to find the next term. So we've got to find the error on the P3. Okay, so I'm going to go plug in 2 here, and I get 5 times 2 to the 5th, all over 5, 2 over 2 to the 5th, over 5 factorial. So I get 5 over 5 factorial, which is the same as 1 over 4 factorial, which is 1/24th, which is less than 0.1. So what is our conclusion? The P3 works, but the question said how many terms? You just need 2 terms. Okay, because it did say how the minimum number of terms. Well, in this case, there were 2 non-zero terms. I would rather see them ask the question P3, okay, but they're 2 non-zero terms. So hopefully this helped. If you have any other questions, feel free to email me. I felt that these were probably the ones that gave people the most trouble, especially 43, and I'm not expecting 43 at this point, but that's the one we need to work towards before the AP exam. Okay? Thank you. Have a good day.